Hey guys, today we're going to take a look at applying Pascal's triangle. Now this is by far my favorite lesson of the course, so you are in for a treat. So, first of all, we're going to look at a question here where we've got a bunch of buckets, okay? So Pascal's triangle, let's go through what it says. Pascal's triangle can also be applied to counting paths or routes between points, and this is what we're going to do. We're going to look at different ways, how many different ways can we get to a different point if there's lots of different branches on how to get there, okay? So to use Pascal's method, we can look at these buckets here. So what we're going to say is we're going to go through. So how many ways can I get to this bucket here? Well, there's just one way to get into the bucket. I just pour right into the bucket. Okay, to get into this second bucket here, well, it has to come down here and into here. There's no other way to get there. So there's only one way into that bucket as well. Similarly, this bucket, I can go in here and then in here, and that's the only way to get to that bucket. And thirdly, if I want to get to this bucket, I have to go here, then here, then here, and that is it. There's only one way, and you can see that this is going to match all the way down here. If you're going to get to the ends or to the edges of the buckets, that's the only way to do it. Now, to get to this bucket here in the middle, I could go from here to here and to here, or I could go from here to here to here. So there are two ways to get to that bucket. Similarly, we got this guy here. Well, we can go here to here to here to here, or we can go here to here to here to here, or here to here, to here, to here. Nope, I already did that one. Sorry. Here to here to here to here. There we go. There's the other one. So there's three possible ways, and same with this one here. Okay? So, overall, how many ways can you get to each bucket? Well, 1, 3, 3, 1, which is exactly the third row from Pascal's triangle. So how do we use it in a more practical sense? Well, this one's not going to seem very practical, but that's fine. So how many ways can we spell Norris given this sort of branch here? So we're just going to go through and we're going to say how many ways can we get to each letter. So we start with N, and there's only one way to get there. Both of the O's, just like the edges of the triangle, there's only one way to get to each. Same with these outside R's. But then this middle R, of course, we can come from here or we can come from here. So there are going to be two ways to get to that R. Now to get to the R's in the next row, we can come from here or we can come from here. And of course there was one way to go from this one and two from this. So we're going to have three ways to get to that R and three ways to get to that R. Now to get to the I, the first I, it has to come from here, which means there are three ways because it could go any of those three ways to get to that I, or to the R, but then it had to go to the I. And the same is true with this one on the edge here. There's three ways. Now the one on the middle, there are three ways to get to that R, three ways to get to that R, and it has to come from one of those two, so there are going to be 6 ways to get there. Okay, and the S's, it has to come from here or here, which there are 3 ways and 6 ways, so there's going to be 9 ways to that S and 9 ways to that S. So how many ways can we spell Norris? Well, we have to end on one of the S's. There were 9 ways to get to each, so 9 plus 9 equals 18 ways. All right, there we go. So, Mr. Hall is going to a Blue Jays game. I am 4 blocks east and 3 blocks north from the Rogers Center. How many ways can I get there if I only go south or west? So the easiest way to start these ones is you want to just go along the edge because it does follow these same Pascal's rule. There are Pascal's triangle rules. So, the other thing that it's worth mentioning is, of course, the locations we're looking at. Sometimes people get confused and they look in the inside of the boxes. The locations we're going are these locations. These are the intersections of the street, and so that's where we're assigning numbers. We're assigning numbers to get to each of those locations. Okay, so for the first ones, we're just going to have one way to get there, one way to get there, one way to get there, and one way to get there. One way there, there, and there. Because the only way I can get to this spot here is to walk all along this path. That's the only way to get there. So there's just one way down both sides. Now, to get to this point, I can come down from here, or I can come from here, which means there's going to be two. And so you'll see that you just look at the points before each point, and you're just adding them up. Okay, so there's two ways to go from here, one to come from here, so this is going to be 3. Two ways here, one from here, so this is going to be 3. 3 ways here, one here, so there's going to be 4 there. Okay, and so we'll have 4 there, we'll have 5 there. We got 3, and we've got 3, so we're going to have 6. 6 and 4 gives us 10. 4 and 6 gives us 10. 10 and 10 gives us 20. 5 and 10 gives us 15. And 15 and 20 gives us 35. Okay? So we can conclude then, there are 35 paths. Okay, and that's it. So let's look at a more challenging one. Oops. So we're going to look at the checkerboard. So here we go. So we got a normal checker. The checkers can only, I don't know if you play checkers, but you can only move diagonally here. Okay? So how many ways can I get to each square with the goal of getting to the end line? So I'm trying to get to this line here. Okay? So let's zoom in here. Okay? So there's one way to get here, one to get here. I can't go backwards, so I can only move along the edge like that. It's a good idea to start by writing out your ones. Once you figure out your ones, everything else just becomes adding. So I can come from this way or this way. So I'm going to have 2, and you're going to notice that the first couple just look exactly like Pascal's triangle. And so we're going to have 4, 6, 4 as well. Now, this is where it gets a little different because, of course, we can't go out further that way. So we'll have 5, we'll have 10, we'll have 10, and 4. So this is the first one that differs from Pascal's triangle, but it's following the same rules. To get to this spot here, I have to come from that 5, so there's only 5 ways to get there. I got 15 here, I got 20 here, and I got 14 here. And then finally I've got 20, I've got 35, I've got 34, and I've got 14. So if I just add all of those up, I get 20 plus 35 is 55, 89, 99, 103. Okay. I think I did that right. Looking at my answer, and it looks like I made a mistake on my answer. But anyway, I don't see anything wrong with that. So there we go. All right. Question 2. Same as part 1, except that we can't travel through the X. So I've blocked off a spot. Now, I believe so in your homework, be careful because there are some questions that look similar to this, but they're slightly different. I think they let you jump over the X, but I'm not allowing you to jump over the X in this case. So we're going to start with our ones, the same as we did the last one. There we go, and then we'll just proceed until we get to the X. So we got 2, we got 3, we got 4, we got 6, we got 4, we got 5, we got 10, and we've got 4. So this is where things get a little tricky. So here we've got 5. Here we can't come from the X, so we've only got 5. Here we can't come from the X, so we've only got 10, 14. And then we've got 10, 15, 24, and 14. So again, we can add them all up. How many ways can we get there? Well, we get 25, 49, 59, and 63. So Do I have room? No, I don't have room. So equals 63. There we go. All right, and that's it. So the more complicated ones, these are the really fun ones. Now again, the mistake people do make here is be very careful because we're trying, again, these dots are the important part. It's not the squares, it's where the paths cross that we're interested in, okay? Like that. I'm not going to do it for all of them. Okay, but let's go through. And again, best course of action is to start with your ones. We got 1, 1, 1, 1, 1, 1, 1, 1. And then we go through and we start with 2, we got 3, we got 4, we got 3, we've got 4, we got 6, we've got 10, we've got 10, and we've got 20. All right, and this is where things are going to get a little complicated because I've removed a path. So to get to this one here, there's actually only one way because I can't come from the 4, I have to come from that 1. Now, when I come from this direction, I can come from the 1 or I can come from the 10, so this one's going to give me 11. Okay, and for this point here, we either have the 1 or the 1, so we have 2. And then we'll have 13, we'll have 31, 44. Okay. Along here, I have to come from the 20, so that's going to be 20. That's going to be 20. And then we'll have 51 and 71. And we'll have 95. And then let's just adjust myself here. So we're going to have a 44 there, and we're going to have 44 there. Okay. So now, right here, we got 95 plus 71. So we're going to have 166. And then we'll have 139. And we'll have 183. And we'll have 305. And then finally, we will have 488. So, are 488 paths. Okay. There we go. So part B is exactly the same. It's just a little bit bigger. So I would actually recommend at this point that you pause the video and actually attempt this question all by yourself and see if you can get the same answer. And so I'm going to fill it out. Zoom in. That's a 58. That's hard to read. Made a little bit of a mess. That's going to be 160. We'll have so finally, you have 1048. And that's it. So there you have it. So until next time, go Sabres.